Hello and welcome to day 3 of Jamb Physics in 40 Days. Now, Jamb Physics in 40 Days is a series that is brought to you by Oya Learn, where we believe that by you dedicating within 30 to 45 minutes of your time daily, you'll be well on your way to acquire all the necessary skills you need to be able to master and ace Jamb Physics. Now, in day 3, what we'll be looking at is motion, and these are the topics that are under motion that we need to master. First, we have to understand what motion is, which is the change in position of an object with time. And then we should know that there are different types of motion. Now, the types of motion that we often talk about in this context are linear motion. We also have the random motion, we have oscillatory motion, and then we have rotational motion. Those are the four that we are going to be talking about as regards this topic. And then we have the relative motion, which is the motion of an object as viewed from the perspective of an observer in another object. So like when you're looking at the motion of object A from the perspective of object B, that is relative motion. And as far as the cause of motion is, what we are looking there is to be able to define what force is and how it causes motion. And then from there, we'll be able to look at types of force. These are things that you just need to look through and brush up. That's why I'm just giving you little snippets at this point. So for types of forces there, we have the contact forces and non-contact forces. And for your contact forces, we have force of push or pull. We also have friction as a contact force. And then for the non-contact force, we have force of magnetism, electrical forces, and so we also have a linear motion where we're going to look extensively, especially in areas such as the velocity time graph, equations of a linear motion, where you have equations such as v equals u plus at. You also have something as s equals ut plus half at squared. We also have v squared equals u squared plus 2as. These are the three equations of linear motion. Then from there, we should also look at our projectiles. You should brush up on projectiles, and the three major formulas we work with on dealing with projectiles is time of flight. Time of flight is 2u sine theta over g. We also have the maximum height of a projectile, which is given as u square sine square theta over 2g. Then we have range, which is given as u square sine 2 theta over g. These three equations are going to go a long way to help you solve problems on projectile. And of course, you should be able to work around them, especially with the angles. Then we should also learn about the Newton's law of motion. It's expected that you should be able to solve problems on Newton's law of motion. There are three laws there. We have the first law known as the law of inertia. That is, an object will remain stationary unless it is acted upon by an external force. The second one, which has to do with a rate of change of momentum with time. And that's where we come about that equation that says force equals mass times acceleration. And then the third law of motion, which states that all forces are equal and opposite. That is, to every force, there is an equal and opposite force. Okay, then there's a motion in a circle, which is also a type of motion. We're going to look at how you can find velocity when an object is moving in a circle. We're going to look at how to find what we call angular velocity, the force or centripetal force, and centrifugal forces and things like that. So you can brush up on that. And then finally, you should also learn about simple harmonic motions. There are quite a lot of questions that can come from all of this. And Jamb expects that as a candidate taking the exam, you should be able to solve problems on these highlighted topics. Now, to help you, I will display now some formulas that you should know that will help you, especially on these different highlighted topics. So as we look at the questions, we will be applying some of these formulas that you are seeing right now on your screen. So if you're ready, let's go on now to solve some problems on motion. Particles of a mass 10 to the power of negative 2 kilogram fixed to the tip of a fan blade, which rotates with angular velocity of 100 rad per second. Now, if the radius of the blade is 0.2 meters, the centripetal force is So we have to find the centripetal force of the particle that is at the tip of this blade. Now, to solve this, centripetal force is given as mv squared over r. But the velocity we are given here is angular velocity, not linear velocity. So we are going to use the relationship between linear velocity and angular velocity to solve this. And that relationship states that v equals wr. So let's rewrite this. So fc therefore becomes m. In place of v now we'll have wr in brackets squared all divided by r. So what we have here is m w squared r squared over r. So this cancels this out. Centripetal force is therefore mw squared r. Now let's put in the values we have and then solve. So the centripetal force there therefore becomes mass. We can write this in positive index. It will become 1 over 10 squared, which is 100, multiplied by w squared, and that is 100. So 100 times 100. All of this multiplied by the radius. The radius is 0.2. So here we see 100 cancels 100. So what we have is 1 times 100 times 0.2. So the centripetal force is therefore 20 newtons. So the correct option is option B. In this question, we're told that if a wheel 1.2 meters in diameter rotates at 1 revolution per second, calculate the velocity of the wheel. Solution. Now, the information we have here is that the diameter is 1.2 meters, which implies that radius becomes half of this. That's 1.2 divided by 2 in meters, and that will give us 0.6 meters. And then we are also given frequency, 1 revolution per second, so that is 1 hertz, or you just say 1 per second. Now we are to find velocity v, which is equals to wr, but w itself is 2 pi f. So we can then apply that here and say v equals 2 times pi, which is 22 over 7, times f, which is 1, times r, 0.6. And when we compute this with your calculator, it should come about 3.7699 thereabout. And this is approximately 3.77 meter per second. So the correct option is B. In this question from UTME 2008, a motorcycle of mass 100 kg moves around a circle of radius 10 meters with a velocity of 5 meters per second. And we are asked to find the coefficient of friction between the road and the tires of the motorcycle. Now, the relationship between this, how we can get the coefficient of friction is actually given from this formula, where F equals the coefficient of friction multiplied by normal reaction. And what this implies that the coefficient equals to F over R. Now take note, this F here would be the force acting on the bike in the direction in which it is traveling. And that force is the centripetal force, right? So we're going to be looking for Fc here. And normal reaction is just the mass of the bike times acceleration due to gravity. So let's break it down one after the other. Fc will be mv squared over r, which would be 100 times 5 squared over 10. Now what this gives us is now 100 times 25 over 10. Now 10 here 1, 10 here 10. So what we have is 250 newtons as the centripetal force. Now normal reaction R equals mg. So that will be 100 times g, which is often taken as 10 meters per second squared. And what we have here is 1000 newtons. Therefore, the coefficient of friction would then be centripetal force, which is 250 newtons, divided by, this ought to be 1000. Okay, so R, which is 1000 Newton. So Newton cancel Newton. It does not have a unit. So what we have is 1 over 4, which is 0.25. No units. So the correct option is option D. A short chain is sometimes attached to the back of a petrol tanker too. And now in this case, we see that oftentimes when we see petrol tankers, there's usually a chain behind them that is just let off, right? Now, although this is hardly in practice nowadays, but back then it's always a common thing to see around, right? This is because as the vehicles move, not just tankers now, generally as we move and break through air, the friction between the object moving and the air rushing in the opposite direction causes charges to build up. And now imagine that for something that is carrying something as flammable as petrol, right? You wouldn't want any of those charges to spark and then lead to fire. So what that chain is there for is to discharge the vehicle. So it is taking those charges to the earth. So the correct option in this case will be option D. What is the acceleration between 2 points on a velocity time graph which has the coordinates? Now we're given these two coordinates. Now one thing we should know from velocity time graph is that the gradient of any portion of the graph gives you the acceleration within that point, right? So if these are the coordinates of the 2 points, right, to find the acceleration, we therefore will find the gradient of these points. So solution, the acceleration would therefore be gradient according to what we know, y2 minus y1 over x2 minus x1. So applying this, what do we have? Acceleration A is therefore, now the y2 is 35 minus y1, which is 15, divided by, remember this is in meters per second, and then x2 is 20 minus x1, which is 10. This one is in seconds. Now when we take this here, what we have here will be 20 meters per second over 10 seconds. So acceleration is therefore 20 divided by 10, that will give you 2.00, so meter per second squared. The correct option is therefore D. An object of mass 80 kg is pulled on a horizontal rough ground by a force of 500 newtons. Find the coefficient of static friction. We were given that acceleration due to gravity is 10 meters per second squared. Now, before I go on to solve this question, if you are yet to subscribe to the channel, please kindly do so. By subscribing, you're helping us to be able to create more helpful videos like this. And also don't forget to share the videos to as many who are in need of this kind of content that we are creating. So please share it and also like the videos and also click the notification bell icon so that you get alerted every time we put out a new content. Okay, so now to solve this problem, we're going to apply the equation for coefficient of static friction. The coefficient of static friction is given as force over normal reaction. Now, we should also know that normal reaction is mass times acceleration due to gravity. So this coefficient therefore becomes F over mg. Now let's apply that. F is given as 500, so 500 newtons over mg, that is mass, which is 80, times g, which is 10. This will also be in Newton, so Newton cancel Newton. So what we have is basically 500 over 800. 0 cancel 0, 0 cancel 0. Now this would give us 0. Now in 50, that would be 6. Remember 2. In 20, that would be 2. Remainder 4. In 40, that will be 5. So 0.625 being the coefficient of static friction. Now the options given here are to 1 decimal point. So let's approximate ours also. That will be 0.6. So the correct one will be option D. A car moves with an initial velocity of 25 meters per second and reaches 45 meters per second in 10 seconds. Now we have to find the acceleration of the car. Now when you find a question like this, to solve acceleration, you should know that acceleration is change in velocity with respect to time. So acceleration will then be final velocity v minus initial velocity u all over time t. Now this is from the first equation of motion. This is what leads to the first equation of motion, known as v equals u plus at. So applying this, we can then solve for acceleration. And we'll say a equals v, which is 45 meters per second, minus u, 25 meters per second, all divided by the time, which is 10 seconds. Now this would give us 20 over 10, and our answer will be in meters per second squared. So acceleration is 2 meters per second squared, the correct option being A. The surface of a conveyor belt is made rough so as to, now we say we're looking at surface of conveyor belts. Now that conveyor belt that we put load on at the airport and other places like that, that carries it from one point to the other. Now that surface is often made rough due to one of the laws of friction, which says that friction depends on the nature of the surface of the material. That is, the rougher the surface, the more the friction, while the smoother it is, the less the friction. So the purpose for that is just to ensure that whatever load you put on it does not slip off as it is carrying it from one point to the other. So the correct option in this case is option B. A force F required to keep a 5 kilogram mass moving around a circle of radius 3.5 meters at a speed of 7 meters per second. Now, what is the speed if the force is tripled? That is, if we triple this F, what will happen to velocity V? So first, let's find the value of F. F becomes mv squared over r, which is basically mass 5 times velocity squared. Velocity is 7, so 7 times 7 over radius 3.5. This here 1, here we have 2. 5 times 2 is 10. 10 times 7, we see that the F is 70 newtons. Now when we triple this, triple F will be 3 times 70 newtons, which will give us 210 newtons. Now using this, let's then find the value of V. From this, we can say that V equals the square root of force times radius over mass. So applying this, the force is 210 multiplied by radius, still 3.5, all over, now mass is 5. So V here becomes the square root of, when we compute this, we should get 147, and then our final answer is 12.1 meters per second. So the correct option is option C. This question from 2008 says, a body of mass 4 kg resting on a smooth horizontal surface is simultaneously acted upon by two perpendicular forces, 6 newtons and 8 newtons. Calculate the acceleration of the motion. Now, force equals mass times acceleration, which implies that acceleration is force over mass. However, in this case, the force here would be the resultant of the two forces acting simultaneously. So let's find F. F becomes the square root of 6 squared plus 8 squared. This will give us 36 plus 64, that is 100. So our resultant force is 10 newtons. So now let's find acceleration. Acceleration is therefore 10 newtons divided by the mass of the object, which is 4 kilograms. So 10 newtons divided by 4. kilograms. This would give us 2.5 meters per second squared. So the correct option is option A. In this question from 2009, it says a car accelerates uniformly from rest at 4 meters per second squared. Now, how far will it travel in the 5th complete second? Now, to solve this, let's pick out all the facts from the question. So we see that it starts from rest, so which means initial velocity is going to be 0. And then acceleration is given as 4 meters per second squared. And time is given as 5 seconds. That's about it. And we're asked to find the distance, displacement s. Now, when we look at the equations for linear motion, we have v equals u plus at. We have s equals ut plus half at squared. And then v squared equals u squared plus 2as. Of these three, only one will work to solve this problem. Now, what I advise students, just write out what you have and then pick the equation where you only have the unknown there and then those other parameters are present. If you should find any of the equation where you have two things that are unknown, then don't use that. Like in the case of equation 1 here, you see we do not know v, right? And s, which is what we are looking for, is not even present here. So this equation will not work for us. And the same thing applies to equation 3. We do not know v, even though s is present here. So there will be two unknown and we don't want to use that. So instead we use equation 2 here. So we go on to say s equals ut, which is 0 times t, being the time 5, plus 1 over 2 times a, which is 4, times t squared, 5 squared. So this one is 0. So s therefore becomes 1 over 2 times 4 times 25. Now, 4 divided by 2 will give you 2. 2 times 25, and then we have 50. So 50 meters. The correct option is option B. A machine gun with a mass of 5 kg fires a bullet of mass 50 grams at a speed of 100 meters per second. The recoil speed of the gun is... So in this case, we're going to be applying the Newton's third law. So to every action, there's an equal and opposite reaction. So therefore, the momentum of the gun and the momentum of the bullet has to be equal. So momentum is mass times velocity. So momentum of the gun, that's mass of gun times velocity of gun, equals mass of bullet times velocity of bullet. Now the mass of the gun is given as 5 kg times v, which we do not know, v of gun. Then mass of bullet is 50 grams divided by 1000, and that will be 0.05 multiplied by the velocity, which is 100 here. Yeah? So what we're going to have here is that 5 Vg equals, when we multiply this will give us 5. Now, dividing both sides by 5, velocity of the gun is therefore 1 meter per second. So the correct option is option C. Two objects, one having 3 times the mass of the other, are dropped at the same time from a tall building. When they are above ground, the two objects will have the same. Now, what do they have in common? Now, keep note that the mass of one of the objects is 3 times the mass of the other. So the first option we have is momentum. And momentum is mass times velocity. So since one of them has more mass, definitely they cannot have the same momentum. Same thing applies to kinetic energy, which is half mv squared. Mass is involved, so they can't have the same kinetic energy either. And the same thing applies to potential energy, which is mass times gravitational acceleration times their height above ground. So since mass is involved there, they have the same height, they have the same gravitational acceleration. So mass is the only thing that differentiates them there. So potential energy will not be the same. However, option D says acceleration. Yes, they will have the same acceleration, and because they are falling to the ground, they will have the same acceleration due to gravity at that point which they are falling. So the correct answer is option D. This question says two bodies have masses in the ratio 3:1 and they experience forces which impart to them accelerations in the ratio 2 to 9. So now we have to find the ratio of the forces that the masses experience. Now, in order to solve this, let's first establish that force equals mass times acceleration, which means the force by the first body will be the mass of the first body times acceleration of the first body, and F2 will also be M2A2. Now let's go to what we have here in the ratios. Okay, so because if you are looking for the ratio here, F1 over F2 is supposed to be M1A1 over M2A2. So, but from the ratio, we can then find the values of some of these with respect to each other, starting with masses. Now, for the mass, we have that M1 over M2 equals 3 over 1. Now, what this implies, rather, is that M1 equals 3M2. Now, let's apply the same thing to acceleration. A1 ratio A2 is 2 over 9. Now, this implies that 9A1 equals 2A2. So that is A1 equals 2A2 over 9. Now, let's come to this equation here. So, F1 over F2 would therefore be, now let's put in the values, starting with M1. M1 is 3M2 multiplied by A1, which is 2A2 over 9, all divided by M2A2. So this 9 will come down here, and then we have 3M2 times 2A2 over 9 times M2A2. So this cancels. Now what we have here is 3 here 1, 3 here 3. So F1 ratio F2 is going to be 2 over 3, which implies 2 ratio 3. So the correct option is option C. Now there are so many other questions you will find on motion as you begin to study more on Jamb past questions on motion. So please try your hands on as many as you can find using the examples that we have given you in this video. However, if you come across a question and you don't understand what to do by that, you can just simply reach out to us by dropping that question in the comment section of our videos. And I promise you we'll definitely attend to every one of your comments. And as usual, don't forget to like, share, and subscribe to the channel. Thank you. I'll see you in the next video.